Hello everyone, welcome back to my YouTube channel, and in today's episode I'm gonna show you how I built this amazing recommender system able to recommend animes based on your watch history. I built this application using a model from Google. I also use Qdrant as a vector store database and Streamlit for the front end. And let me quickly show you how this application works. I just need to click here and choose a user ID from the database, and then I will be able to provide a recommendation of animes based on their watch history. So if we choose this one and then we click on recommend, we can see a recommendation of 5 animes for this specific user. Here we have the English name, the Japanese name, and then here we have the rating and the genres. And this information can be extremely useful when they are looking for an anime to watch. And I'm gonna show you step by step how I built this amazing application. The technique that we will be discussing today is content-based filtering, which focus on recommending items based on their similarity. For example, in this case, we will take the watch history of a user and identify similar animes that they have watched. For instance, if the user watched anime A and we know that anime A is similar to anime B, the algorithm will recommend anime B to the user, and that's what we will be checking today. If you're enjoying this content so far, don't forget to subscribe to the channel by clicking on this button because it helps me to create more content. Also, smash the like button, turn on the notification bell so you never miss a new video. And this is the workflow that we will follow today. We have a database that contains the rating of every anime that the user has watched and also the description of the anime. And based on the description and the watch history of that user, we will be able to recommend other animes. So we will take the description of the anime and we will transform it to a vector of numbers. And for this, we will need to use an embedding model. In this case, we will use an embedding model from Google. I have an example here of an embedding model. So an embedding model will take this text and will transform it to a vector of numbers, and this vector of numbers will be saved Qdrant. So in Qdrant we will have embeddings of each one of the animes that the user has watched. So by the time that we want to recommend animes to this user, we just need to take the watch history. In this case, the user has watched these 3 animes. The user likes anime X and anime Z, but dislikes anime Y. So we will take this into consideration while calculating the similarities between these 3 animes and the animes that we already have in our vector store database. So here we can see that the user likes X and Z and dislikes Y, and these are 6 animes that the user might like because the embedding, the content of these animes are similar to the content of anime Z and anime X, but they are not similar to the content of anime Y, and therefore we will be able to provide these recommendations based on their watch history and preferences. And now let me show you how to do it in Python. We will need to install all these libraries. In my case, I already created a virtual environment which is isolated and has all these libraries installed. Also, you will need to have a Qdrant API key to insert the collections in the vector store database. I have a video in which I explain thoroughly how to get the API key, and I will be leaving this in the description below so you can know how to get all these values. And now we can start coding. So I'm gonna create a source code Python package where we will have all our code, and here I will create a file to upload the collections, the documents which are the content of the animes to Qdrant. So let's call it insert collection Qdrant. Let's call it like this. As a first step, let's load our datasets, which are located in this path. So for this, let's import pandas, and then let's load the dataset. Let's call the first one the f_anime. For this, let's use red CSV, and here let's specify of this dataset. Let's run this, and here we can see the df anime. If we want to see the columns of this data frame, we can see that this data frame has the ID of the anime, the name, the rating, the genres, and the description of the anime. And this description we will pass it through an embedding model that will transform the texts into a vector of numbers that we will send to Qdrant. Also, let's import another data frame that contains the rating that a user has given to the animes that they have watched. Let's call it the f users with rating, and then let's do pd.readcsv, and now let's specify the path of the data frame. In this case, it's called the f users with ratings sample. Let's check the columns of this data frame so you can have an idea of what it has. Here we have the user ID, the anime ID, which is the same as mal ID, the rating that the user has given to this anime. Here what we have is the average rating of every anime, but here is the rating of every anime that the user has watched, whether the user has finished the anime or not, and the amount of episodes that they have watched. So based on this information, we can proceed to send the data to Qdrant. So now let's import an embedding model. Let's use an embedding model from Google to transform all the descriptions to a vector of numbers. let's call this embeddings model. And here we'll specify the model that we will be using today. In this case, it's a model from Google, so let's import it. Now that we have imported the model from Google, I'm gonna give you an example of the output of the model. So let's transform this text to an embedding. So for this, let's use our embedding model, and then let's specify embed query and provide here text. Here you can see the transformation of this text into a vector of numbers. And this vector of numbers, we will save them in Qdrant. Something important to know here is that we will need to specify in Qdrant the dimension of our embeddings. It will depend on the model that we use. In this case, this model from Google has as a dimension a vector of 768, and this number will need to be specified in Qdrant. So let's import Qdrant. Let's do import Qdrant client. Also, let's import the credentials. So let's do import OS, and also let's do from .env import load.env. Let's load our credentials. Let's save the first one as Qdrant host. Let's do Qdrant_host equal to OS get env, and here we'll need to specify Qdrant host. Let's import also the libraries. Now let's get the API key credentials. So let's do Qdrant API key equal to OS get environment Qdrant API key. Let's run that one, and also we have a credential for the collection name. So let's save it now, Qdrant collection name, and also specify OS get environment, and here let's specify Qdrant collection name. And here we can see that everything was loaded correctly. Now let's proceed to do the client connection. So let's do client connection equal to Qdrant client, and there let's specify the host. So let's use Qdrant host. Also we will need to specify the API key, and also let's specify a timeout of 50, for instance. Let's run this. Everything is working well. And now let's proceed to create our client collection. So let's use the client connection that we created, and here let's specify create collection. We'll need to specify a couple of parameters such as the collection name. We can get it from the environment variable that we just loaded. Also we'll need to specify a configuration of our vectors. So let's do vectors equal config. I will create it in a moment, and also let's specify a char number. So we will partition this database. So for the vectors configuration, here we'll need to specify the configuration of the model that we're using to transform the text to embeddings. So let's call it Qdrant vector config equal to, here let's specify Qdrant client.http.models.vector_params. And here we'll need to specify the size of our embeddings, and we saw earlier that it had a dimension of 768, and we will also need to specify the distance that we will use. In this case, let's do Qdrant client.http models, but in this case let's specify as a distance cosine. So we can assign in vectors config this configuration. Also from Qdrant we will need to import the module called models. So let's do from Qdrant client port models. So let's execute this. Now that we just created our collection, we can proceed to insert the embeddings to the database. So for this, let's import from LangChain community Qdrant. From LangChain community.vector stores, and here let's specify Qdrant. Import Qdrant. Now that we have imported Qdrant, let's proceed to insert the document. So let's do vector store equal to Qdrant, and then here we'll need to feed as parameters our client connection. So client equal to client connection. Let's also specify the name of the collection and the embedding that we'll be utilizing. In this case, we call it embeddings model. So let's execute this. And also we will need to transform all the description of animes to embeddings. I already have a function here that can do that for us. We just need to apply to our database. So let's do 𝑑f_anime, and then let's create a new column that will be called vector embeddings, and this column will have the numerical representation of the content of each one of the animes. So let's do 𝑑f_anime. So let's run this. Well, we'll need to execute this first, and then let's run it again. Now that we have our function created, it's executing and applying in each row of the content the transformation of the text to the embeddings. In the meantime, let's also add metadata in our collection. So let's do payloads equal to 𝑑f_anime, and here we'll need to specify the columns that we want to have. So let's add the ID of the anime. Let's also add the name, the Japanese name. Let's also add the genre, the score, and the URL of the poster of the anime. And let's save this as a dictionary. So let's do toDict and specify records here. Let's execute this, and now let's check the payloads. Here we can see the payloads, which is a list of dictionaries that have the ID, the name, the Japanese name, the genre of this anime, the score, which is the average rating score for this anime, and the URL where we can find the poster of the URL that we will display Now that we have our payloads created and also our embeddings are generated and applied to each one of the animes, we can insert those embeddings to our collection quadrant. So let's do that now. Let's do client connection.observed. Here we will need to specify the collection name. Here in points we will need to specify the vectors that we want to upload. Here let's specify models.batch and then what we want to insert in Qdrant. So we want to insert our vectors, which are these ones that we created earlier. We will also specify the payloads. Also, we will need to specify an index. So let's do IDs df_anime.index, and then we can execute this code. So let's do that now. And now we are inserting into the Qdrant collection all the embeddings that we just generated and also this metadata. And if we go to Qdrant, we can see all the information of our vector store database. Let's quickly check it out. Here we can see that we have a collection called Movie Recommender, and here we have all the embeddings of all the animes that we have in our database. Here we can see that this is an embedding of one anime. Here we can see the genre, the Japanese name, the ID, the name, the rating, and the URL of this poster. And now let's say that we want to make a recommendation for one user. We can just do client connection, and then here there is a function called recommend that will allow us to perform approximate nearest neighbor. Here we will need to specify the collection name. So let's do collection name equal to Qdrant collection name. Also, we can specify the animes that the user likes. Let's specify that in this case, the row 1 contains an anime that the user has watched and also like it. And also let's specify negative. And here we'll specify the animes that the user has disliked. Let's specify that anime in row 0, the user disliked it. And also let's specify a score threshold. And this threshold is the minimum similarity needed in order to recommend an anime. So let's specify, for instance, 0.1, and this means if the similarity between the anime that the user has watched and the other animes that we have in our vector store database are below 0.1, those animes will not be recommended. But if the similarity of the content of this anime that the user has watched and the other animes are above 0.1, those animes will be recommended. And also we can specify a limit, which is the amount of recommendations that we want to provide. For instance, let's say 3, and execute this, and you can see how this will generate 3 recommendations for a user. Here we can see the 3 recommendations provided for this specific user. Here we can see the URL of the first recommendation, the URL of the second, and the URL of the third recommendation. So everything is working as expected. And now we can proceed to create the front end of our application. So for this, let's create another Python file called app.py that will contain our Streamlit app. Let's create the file here, app.py, and then let's import Streamlit. Streamlit as is. Let's configure the page. So let's do set page config, and here we'll specify the page title, which will be anime recommender. Also the layout wide, that's what I'm using now. And also let's specify as an initial sidebar state expanded. This information that we just assign here, we can see it here in the title of the page. We can see anime recommender, and also we can see that the layout is wide, and here we can see that the sidebar is initially expanded. Also, something that will be very useful for us is to create a utils file, so we can keep this app.py as clean as possible. That will increase the readability of this file. So let's do utils.py, and here we will import, for instance, the dataset, which will be important for us because we will need to identify the user, the watch history of the user, and the candidate movies that we can recommend. So for this, let's do create a function called load datasets. Load datasets. Here let's define the datasets that we will be importing. In this case, we can even take the datasets that we used earlier. Here we can have them again. Let's specify these two. Let's import pandas in this file, and then let's return these 2 data frames. So let's do return the f anime and also the f users with rating. Also, another function that we'll need to create is a function that will generate the recommendations, but let's do that later on. At the moment, we can come here and load our datasets. So let's do it now. The f anime and also the f users with rating. Let's keep the same name that we had earlier, and then let's load the function that we just created. Something that will be useful for us is to load the dataset once and leave it in the cache, so we don't need to load it every time we make a request. So let's add here st cache data. So let's import Streamlit here also too. Now that we have this done, we can proceed with our application. So let's define a function here to create our application. Let's do def main and here let's specify the title. In this case, we want to have in red anime stream, anime recommender. If we go back to the web page, we can see that we have just added this information here. Now we can proceed to add this information in which we welcome to the anime stream, and we specify that it's a personalized anime recommendation system tailored to your watch history. So let's do that now. Well, if you also notice, there's a bit of space here between the anime stream and then this information. So let's do it. So for this, we'll need to specify Streamlit right, and then here we can do the number symbol, and then we can specify in this markdown the information that we saw earlier. Welcome to anime stream, your personalized anime recommendation system tailored to your watch history. Let's add another st.try to have more space between this information and the next thing that we will add, which will be a box in which the user can select the user ID that they want to see and provide recommendations to. So let's do that now. Let's do my expander equal to Streamlit expander, and here we'll specify tab to select a user ID, which is this information that we have here. Tab to select a user ID. Well, let's use the same one that I had in the previous web page, which is this one. Now that we have our expanders, let's specify the IDs that we want to render in that expander. So for this, we'll need to identify the unique user IDs. So let's get the unique user IDs from this dataset. Unique user ID equal to, here we have a column called user ID. So let's get this column and then identify the unique values. And then let's also have them in a list. Now that we have that done, let's get the selected user ID. So let's do selected user ID equal to my expander dot select box. And here let's specify the user ID that we will be looking at. So let's do unique user ID. Now that we have that done, let's create a button that will generate the recommendations for a specific user. In this case, we have this button here, which is recommend. And when we click on it, we have the recommendations for this particular user. So let's do it here. Let's do if my expander dot button recommend. If this button is triggered, the button called recommend, let's perform a couple of steps. One of them will be to provide the recommendations. So let's create a function to do this. So let's go back to the utils file and proceed to create these recommendations. I have the function already created, so I'm gonna paste it here and explain it. With this function, we're able to generate the recommendations for the users. So when you select a user in the application, the first step will be to connect to the Qdrant database, and that's what we do here. We specify the host, the API key, and the timeout. And after we connect to the Qdrant vector store database, we proceed to filter our data frame with the user's rating. So in this data frame, we specify that we want to have all the information of a specific user. In this case, we will have all the animes that this user has watched and also the rating that the user has given to this anime. We will specify that if the rating is above 5 out of 10, we say that the user considers this anime as a good one. So we have here as high rating. And if the user gives score below 5, we consider this as an anime with a low rating. And now that we have identified the animes that the user likes and dislikes, we need to identify the index of these animes in this data frame. Because earlier, when we were inserting the animes in the Qdrant vector store database, we specify an index of these animes. So this index, we will need to find them again. So in this case, I'm just getting the index of the high rating animes and the index of the low rating animes. And these indices, we will provide them to this function. In this function that we saw earlier, we saw that we need to feed the collection name, which in this case will be the movie recommender. Here we will specify the index of the animes that the user likes, the index of the animes that the user doesn't like, a score threshold. In this case, let's use 10%. So we're setting as a minimum number 0.01. So if the similarity between the animes that the user likes and any other anime that we have in our vector store database is below 0.01, it will not be recommended. But if it's above 0.01, it will be recommended. And don't forget that the recommendations will be made on the similarity of the content of each one of the animes. And also here we specify k amount of recommendations that we want to feed. And here we will also need to provide the credentials to connect to the Qdrant vector store database. So let's do that now. Let's load our credentials. Let's see if everything is working as expected. Well, we will also need to import Qdrant client, so we don't have any more errors. Here we can see that we sort out the list of recommendations, because you can see here that each one of the recommendations have a score. Let's say in this case it's 0.5, in this case 0.56, and in this case it's 0.60. So we are sorting them out from higher to lower. lower, and then we also extract information that we're interested to present in our application, such as the name of the anime, the Japanese name, the rating, the genres, and the URL, because with this information we will render the poster when we identify animes that we want to recommend for that specific user. Also, we will need to import the credentials for Qdrant. We want to access to the vector store database, so let's do that now. Let's come here and import all the credentials like we did earlier. And also we will need to import Qdrant client. So let's do it now. Let's see if everything is all right here. Okay, there are no more errors. And let's go back to our app.py and continue creating the front end. And now let's create a functionality in our app that will trigger the function if someone selects a user ID. So let's do anime info equal to, let's get function that we just created, which is generate recommendations. Let's paste it here, and also let's define these arguments. So the data frame user is the data frame that contains the rating of every anime that the user has watched. So let's paste it here, and for the user ID, let's specify that we want to have the selected user ID when you click on the button. The DF anime ratings, this one contains information of the anime itself, so it's DF anime. And also let's say that we want to provide 5 recommendations. And now let's proceed to create 5 columns so we can present the recommendations of the animes one next to each other. I have code also here, so I'm gonna paste it and explain it. Here I specify that I want to have 5 columns, and then we loop this anime info data frame. We write column with the name of the anime. We also specify the Japanese name, and we present this information here. We also wanna have an extra space between the name of the Japanese name and the poster, and then we also want to write the score, which is the rating of the anime in general, and also the genres of the animes, so the user can know more or less if the anime will suit their preferences. Now let's proceed to run this and see if everything is working as expected. And for this purpose, we will need to do Streamlit run and then specify the location of our application. In this case, is in the source folder. And here we can see that our application is up and running. We have anime stream, the anime recommender, which provides a personalized recommendation tailored to your watch history. Here we can specify the user ID, and based on the watch history of this specific user ID, we will provide 5 recommendations. If we click on the button recommend, we can see the recommendations given to this specific user based on the animes that they have watched, the animes that the user likes and also that the user dislikes. So you can play around here and select an ID of any other user, and you could see that it's providing 5 different recommendations. Let's take this one in this case now. Let's click on recommend, and then you will see 5 more recommendations. And that was it for today. In this video, I showed you how to build an anime recommender system able to provide recommendations based on animes that you have watched in the past. For this purpose, we were using Qdrant for our vector store database. We use a Google model to transform the text into an embedding, and also we use Streamlit for the front end of this application. I hope you like this video, and if you have any type of questions, please leave them in the comment section below. Don't forget to subscribe to the channel because it helps me to create more content, and smash the like button below. Don't forget to turn on the notification bell so you can be the first one to know when I upload a new video. See you next time.